care of by certain applications with the help of TensorFlow.js and as well as TensorFlow Lite. And we'll have a few demos on present. The one which I have developed on running some of those applications on these particular aspects of fog computing and implementing the artificial intelligence of things and so on. So let us start. If you see this particular era, this particular decade is all about people talking about Internet of Things. So basically, the Internet of Things is connecting the various physical objects. So the objects can be pertaining to different set of domains, a different set of applications, and so on and so forth. So we use different devices, vehicles, buildings, and all other items which are being embedded with certain electronic gadgets, electronic devices, and with certain software tools. So we make them try to have some interconnections, and we try to realize the data that is getting originated from this set of devices. So basically, we make use of our daily life, a very comfortable and a healthy living, and so on and so forth for various purposes. So if you see the present scenario, the IoT has made us to have the digitization of various aspects on every walk of our life. So if you see on with respect to the transport, the community, the national level infrastructure capabilities, the utilities, the industrialist, and the hospital case, to every walk of our life, you see all these aspects are now getting realized with the help of IoT, and we are making use of these IoT themes for certain purposes and for our own purposes. So during this digitization of connecting the things and getting the data from the things for our better way of life to make our life very comfortable, and as well as to have certain kind of applications to be made use of for certain purposes. We are trying to embed certain smarter techniques onto these things and for their connectivity, and then so on to realize certain things in a very effective manner. So ultimately, what we are trying to do in this particular era is uh, having your artificial intelligence techniques to be embedded with your IoT devices to make our digitally empowered society for a smarter decisions for our better way of our living standards. So when we looking into the aspects of deploying IoTs for various applications and for our society, there are certain issues which are been pertaining to these IoT themes of applications. So the data that is getting generated from these huge collection of uh, things that are getting connected with each other, the management of the data is the most important crucial phase where we try to look into how do we manage that voluminous amount of data that is getting originated from these millions billions of devices that are getting connected. So these devices, when the huge quantity of data is getting generated, so how do you manage them? If you see in the last decade, people have tried to manage this data with the help of cloud-based systems, wherein certain heterogeneity, different set of things and different set of electronic gadgets which are being instrumented for certain set of applications. So there, those set of things are getting realized in the sense the data is getting originated from those different set of things are getting made proper decision with the help of cloud-based IoT systems. Of course, the issues are that there is a high latency in the sense that the responses that you are getting from the cloud computing devices is taking more time, which is inadequate to support certain real-time applications which needs a quicker decisions and a smarter decisions. So one solution for this to handle this set of high latencies which are being handled by the cloud-based IoT systems, the solution that the people have thought is to decentralize the applications to have their management and perform data analytics in a more appropriate manner is by distributing the data to be processed at the data origin itself and to have a federated computing model so that smarter and efficient decisions can be made at the data origin. So the traditional model of storing data and the subsequent data analytics is to push the data up to the cloud. That was what we have seen in the past. But for real-time and near real-time data assessments, the sheer volume of data overwhelms the networks and the cloud systems. So what people and the scientific world and the industries are looking for this is to move the real-time analytics closer to the people who need the data. That is, bringing the data analytics to the things itself. Things in the sense the objects where certain processing takes place at the object near to the data origin, and the smarter decisions also can be generated from the objects itself. So if you look to this process of bringing the processing and making the decisions near to the data objects or the data origin, the IoT themes can be better understood in terms of three different scenarios here. So the first scenario is the data that is getting originated from our physical things. It can be from the electricity, from the water taps, or for the healthcare sector. So whatever the things we try to make use of them for making some smarter decisions. So you collect the data, and once the data has been collected, the data is getting processed very near to the data origin. So with the help of certain electronic gadgets, with the help of certain efficient data processing techniques and data processing tools, we make those processing data is going to held at very near to the data origin. So this particular set of scenario where you are trying to process the data and make some decisions very near to the data origin, we call this particular theme as an edge computing. So entire data is getting processed near to the data origin here. If you look to the second scenario over here, where the data is getting originated from different set of physical things, and the data, whatever the data is being collected, is being put forwarded to the cloud, and the processing is happening at the cloud, and you get back the decisions based on the data that is getting processed over here. So those decisions makes these devices to act accordingly, depending on those particular processed data here. So this particular scenario is basically resembling to what we are now so far seen on the cloud management or cloud computing techniques. So in this kind of IoT cloud-based environment where the decisions are coming very slow, in the sense there are high latency over here, and managing the data over these particular billions of devices which are getting connected is also very difficult at this particular point. So here the cloud computing is also has got certain drawbacks and certain limitations for realizing the IoT themes of applications in a more effective and then efficient manner. So if you look to a third scenario over here, the data that is getting collected from this particular set of physical things are processed very near to this data origin. So with the help of the electronic gadgets here, and certain data which has been processed here is also been put forwarded to the cloud, and to certain extent, to certain level of data that is getting processed here is also getting back some decisions, and that the decisions are being passed on to these physical objects to manage and control these devices in a more efficient and an effective manner. So if you look to these three scenarios, technically we term these particular three different scenarios as the edge computing. The second one is basically the cloud computing strategies and the cloud computing philosophy over here. And the third one is basically a part of that particular data processing, which is processed very near. A part of that one is sent to the cloud for further data processing and to make a wise decisions for a wider set of applications. And the process data can also be passed on to these particular physical devices. So here, this particular third philosophy or the third strategy, what the IoT themes of applications are looking for, is basically the fog computing approach. So there is a very narrow difference between the edge and the fog computing. If you look to the literature, so far some people have had a similar terms with respect to the edge and the fog. But if you look to the a particular difference in a very depth manner, if you look see here, there is a subtle difference between the edge and the fog computing scenarios. So basically, the fog computing is an environment where distributed intelligence is going to be realized here, so that efficient utilization of these IoT teams can be made use of for our day-to-day life very smoother and a very efficient manner. So the issues with respect to the edge and the cloud, which are being augmented with the IoT themes, is basically like this. So IoT edge environment Basically, it supports low latency, yes, because the data is getting processed very near to the data origin. But those low latency responses to the sensitive events may not realize into a better one when there is a more requirement for real-time analytics on a large amounts of data, such as computer vision processings and the multimedia data that is to be processed on this set of the resource constrained devices. So the IoT edge computing do not permit to easily share the collected data across these different set of systems. And of course, there is a limited computing resources available at the edge devices where there is a lot of constraints on the battery as well as on the computing power, on the computing capabilities. So the other aspect, basically the cloud management also requires a stable internet connection where the data has to be transmitted across the different devices and to the cloud. And it also induces higher latencies and the cost to transfer the data to the cloud. Of course, the performance degrades due to the network congestions at the edge and the core of the internet. And these are all the limitations and the drawback of with respect to edge and the cloud. So the more appropriate way to realize the applications to have a distributed intelligence in a better way is to have something called as a fog computing approach. Gartner defines the edge computing as a part of distributed computing topology in which information processing is located close to the edge of the network where things and people produce or consume that information. Whereas the fog computing in IoT is a new paradigm for distributed intelligence where the industrial internet require a greater degree of system intelligence enabled at the edge so that the proper decisions can be made and the smarter and a better way of life can be made use of for. So that is basically a narrow difference between the edge and the fog. So all of you may just please make a note of this one, the difference between the edge and the fog computing. So if you look to the Open Fog Consortium, the definition for a fog is something given like this. Fog is a system level horizontal architecture that distributes the computing, storage, and the networking closer to the users and anywhere along the cloud to the things continuum. So here the fog comes in between the cloud and the physical things that are getting connected with each other to generate the data and to realize the smarter decisions for our day-to-day life. So why we need fog? So the International Data Corporation predicts that by 2025, nearly 45% of the world's data will be moved closer to the network edge. And fog is the only architecture to withstand this amount of data to have distributed intelligence, which enables the IoT, 5G, and of course the 6G and the AI together. So the need for the scale properties basically to look into the security, the cognitions, the agility, the latency, and the efficiencies will make the fog computing to have a better approach for our IoT themes of applications. So fog computing, the basic purpose or the basic philosophy over here is that it pushes the cloud services locally where the data is needed and later syncs to the central cloud for certain data operations to have in a very big picture. So whenever you start to implement or to deploy the fog projects, please be aware that your fog project should not be the first one. Basically, it should be the IoT project. And from the IoT project, you should realize or you should transform that IoT themes of application to the fog concepts so the better network performance characteristics can be handled very easily. And you can try to realize the complex operations and the complex things can be done in a more smarter way for better way of life. So please do first implement or deploy the IoT projects, and from that try to implement certain fog characteristics to make the IoT theme of applications very lucrative. The core to fogging a network is based on the mature cloud services. Of course, the fog computing also because to some extent the data is getting transferred to the cloud. So the services of the cloud is also very much important to us. So if you look to the research aspects, the research questions that needs to be handled very easily for the computing scenarios on the authentications. So this is the basic problem which is already existing on the IoT things to be realized in a better way. Similarly, the security and the data load management. So these are the common issues which are also been persisting with IoT, which is also being considered as a research issues for the fog computing. And better solutions are getting over from the last few years. So people are trying to provide different set of solutions to realize this fog computing in a better way. The another important aspects that people should try to understand over here is a different set of IoT device categories. So if you look here carefully, if you look to a different set of categories from the lower categories to the higher categories of different electronic devices that we make use of in the IoT themes of applications, is starting from the category one, where you have a low-end set of sensing systems which are being instrumented and which has been connected to various set of physical objects to understand the environment and to get the physical objects data in a more efficient manner. We have a small set of sensors and actuators, and which have been instrumented, which have been connected with various other electronic circuits to collect the environmental information here. And those low-end devices may sometimes may be interconnected with little bit high-end sensor nodes or the sensor networks, which are being augmented with the communication capabilities. That is to have a Zigbee, or you have your Wi-Fi or a Bluetooth, as well as some wireless communication protocols which can be easily added onto these set of smart sensing systems. So these are the sensing systems which been falling into the category of category 1 and 2, so which been very much near to the physical objects. So if you look to the next hierarchical level from the lower level, we come across the sync nodes, basically your Raspberry Pis, uh, Jetson Nano devices from NVIDIA, and so on and so forth, where they have a little bit more computing power and more communication capabilities are also being added up onto this particular set of sensing systems. So these are falls under the category of 3. And if you look into the further onto the higher levels, so we have certain mobile systems, mobile as well as the electronic gadgets which suppose more computational capabilities than your Raspberry Pis and Jetson Nanos, then followed by your laptops, your desktops, your workstations, and so on and so forth, your servers and your cloud computing infrastructure to support various other IoT themes of applications. So this is a wide spectrum of different set of devices which may be used for various IoT themes of applications to be realized for effective utilization of those applications. So when we look onto the analytics part, the data processing and to make the smarter decisions with the edge or the fog analytics, we have two different approaches as of now in the market. There are companies like the Dell, HP, IBM, Axon, GE, the Azure, the cloud computing environment. All they have this own set of tools, the hardware and the software tools they provide to realize those IoT themes of applications. So they have their own set of softwares and they have their own set of hardware devices which needs to be deployed onto your application scenarios to make use of those data realizations in a more effective manner. So the first approach basically is to have a special appliance. Basically, these are being manufactured, they are being instrumented with their company's technologies. So they are being basically termed as the IoT edge analytics. So you can buy from the market from those vendors. They have their own set of hardwares and softwares. And the second option is to make your own ad hoc edge devices. You can make combine with the cloud computing with the resource intensive devices as well as with resource constrained devices, and you can deploy them on your IoT applications to capture, store, and process the digital data in the real time. So these are two different scenarios. Of course, because of the open source technologies which are available to us, so we can make use of our own set of IoT gadgets and IoT equipments of different categories. So here, different categories in the sense you can make connection, make use of these devices instrumented at your own laboratory, and you can try to realize those IoT applications in a more effective manner. But if you look to the market scenario, these gadgets, there's equipment, these have been sold by these different vendors are of very high cost. So again, they have been independent and they have been very much homogeneity. They are not been heterogeneity. So you need to highly depend on these set of devices only. So the preferable option is to have your own set of uh, data to be processed and the data to be collected and the data to be analyzed. So if you look to the macro level architecture of your IoT themes of applications, so we have certain physical devices, the physical things which are being at the lower level. followed by the sensors or the actuators and the device controllers, which have been coming to the next level, which are getting added up, which have been instrumented with these physical devices. And if you look to the next level, the category 3, you have an edge computing devices or your fog computing devices with the help of Raspberry Pi. So along with the software tools, we can make use of these a cluster of these particular computing devices to realize a more computing capable infrastructure to have a complex operations to be done, which you can run in a parallel and in a distributed manner. So you can do your data analysis, your edge analytics is very near to your physical objects. And this particular set of scenario will help you for you to handle the huge collection of data and huge quantity of data that is getting originated in a very small amount of time. You can realize that in a more effective manner with the help of your machine learning and AI techniques, which are going to be applied across this different range of activities. So I hope people are able to get on to this. So there's a connection. Yes. So let us continue
Yes,
this. Yeah. Yeah. So I'm just going on my own way. I will give time for our discussions. So we have, so just to make your understanding, after this presentation, we have a demo, then followed by a question answer sessions. But if anyone has got some doubts here, please do keep posting on the chat window. So that you will not miss your doubts here. I will get back to the chat window as quickly as possible during the session. So I'll try to respond to these questions here. Right. So in continuation to this one, so we have just understood about what is an edge computing and the difference between edge computing and a fog computing, and what are the devices which we make use of for realizing those IoT themes of applications for our edge and fog computings. So far this is a topic which you have just tried to understand over here. So now coming to the edge computing challenges. So whenever you try to realize these edge facilities or edge computing to be incorporated at the very near to the physical things, is basically an IoT environment. Edge computing is basically an IoT environment. It's usually dynamic and stuffed with large number of edge and fog devices, where every device is to be blessed with one or more RESTful APIs, basically representational stateful APIs, the application programming interfaces for exposing their unique services to the outside world. So people, a lot of research works is carrying on this, deploying and implementing various RESTful APIs, how best we can make use of these physical things, get connected with each other and collect the data and realize and make a smarter decisions in a more effective manner. So the computing challenges is, of course, the heterogeneity comes into picture, followed by the uh, discovery of those devices which are being deployed on the environment, and how do you manage those devices and collect the data, and how do you make use of those orchestrations in terms of clusters or for deploying distributed intelligence or for uh, applying parallel computing techniques and incorporating the security mechanisms over these set of devices which are getting connected with each other. So here we also look into the how best we have to make use of those resource allocations and the utilizations, mapping those services and applications with the edge devices. So leveraging the fog computing for scalable IoT data centers, when there is flexibility is there, you can deploy more and more IoT devices, and how best you can try to have the elasticity of increasing the more set of fog computing devices to run more complex operations such as your deep neural networks or your machine learning algorithms to be easily deployed on this set of huge set of devices to get a smarter decisions. So edge device traffic management, the data and the protocol, how do we transfer the data, how do we make the understanding, and so on and so forth. So there we also have certain forming of the clouds at the edge and the fog devices and how to manage them. These are all the computing challenges. People are trying to provide different set of solutions and different set of mechanisms. And this is the current area of research where for all these aspects, people are having their own set of ideas, their own set of prototypes, of course, on different environments. Now, in order to realize these IoT technologies, we have certain methods, certain protocols, certain tools, and certain set of hardware devices which are already available in the market. So, with the advancements of the hardware technology, with the advancements of your latest softwares, and the techniques and the mechanisms which have been incorporated. So with the miniaturizations of those hardwares and the electronic circuitry, the instrumentation, we have a better connectivity options are there. We can remotely program all those set of devices, have different set of sensing operations, do incorporate the vision and the perceptions, and do perform the data analysis in a more efficient way. So we have the communication technologies, which are basically your 4G, 5G, and we are coming on to the 6G also. We also have a low cost and high range communication and the low range communication devices. We have the LoRa, LoRaWAN, narrowband IoTs, IEEE's 802.11x, Wi-Fi, Bluetooth, Smart, Zigbee, Thread, near field communication, 6LoWPAN, Sigfox. So different set of communication standards are also available in your market. People do make use of these communication technologies to realize the IoT themes of applications in a more effective manner. Similarly, we have different set of gateways at the fog level and as well as at the network topologies for the star and the mesh networks to have different set of integrations and orchestrations of those frameworks, which by incorporating the message queuing, transport telemetry, you have constrained application protocols, XMPPs, the REST and the RESTful communication protocols here. So you have a wide variety of IoT application enabled platforms which can be easily built up, which can deploy and delivery and have the data processing in a more efficient way. So the IoT gateways, the platforms, the middleware solutions, the databases and applications and cloud environments, all these are now available for us to realize a more effective and a more effective solutions for making the IoT themes of applications in a more better way than the past. And if you look to the technical terminologies of these multi-sensor fusions, so far people have to have realized connecting the different set of devices to connect different set of physical things and with different set of smart sensing systems which have been having different connectivity features as well as different sensing capabilities. So far we have a multi-sensor fusion collecting the data by a single coordinator or distributing the data across different smart sensing systems to realize a better solutions for different set of applications and so on and so forth. So from multi-sensor fusions, that is through your wireless sensor networks, we come across the sensor to the cloud. People are able to send the data from the sensors to the clouds directly with the help of this different set of cyber physical systems and so on and so forth, the different technologies. And we also have different device to device integrations. So on these ecosystems, we can rightly communicate with each other. So these we have the mobile systems as well as with your robots. We are trying to look into these realizations of IoT connectivity options. So similarly, you have device to cloud integrations. The cloud to cloud integrations is also been made use of. So, but now since we have the edge and the fog computing scenarios, people are very much now looking onto the aspects of mobile edge computing, what we call it as a cloudlets, a small fog computing environments here, and as well as the edge cloud formations for forming a different set of clusters of Raspberry Pis or clusters of IoT gateways to have heterogeneous edge and fog devices to connect to each other and collect the data and realize the things. So if you look to our practical aspects, so we do have certain small limited capabilities infrastructure at our place. So we make use of these Raspberry Pis and the smart sensing systems which have been wirelessly connected with each other, and we try to realize certain applications which we run with the incorporating these fog computing capabilities. So if you see the general architecture over here, we do deploy the Zigbees and the Wi-Fi's which are getting connected with these Raspberry Pi gateways, and we try to develop certain APIs to realize this set of things which are getting connected and try to get smarter decisions and so on and so forth. So far you are able to have succeed in implementing certain aspects here. So we have uh, serverless management of software things to be connected with each other with the help of those software APIs which have been deployed on this particular Raspberry Pi. So this is what we have used the infrastructure of uh, uh, OpenFast structure here. So to realize the fog computing onto your cloud. So these are the some of those results. Of course, they are here in the beginning stage itself. So you can get more details on this particular paper. And we have other things which are being carried out some of our research scholars here, which we are trying to have a framework for audio and lighting stimulation for the dementia sufferers using the fog computing in a smartphone. So we have a light stimulating as well as an audio stimulating feature, which which we are trying to incorporate on the Raspberry Pi gateway to realize some of those features. So this we are trying to realize with the help of cluster computing. So we made a cluster of Raspberry Pis for resource sharing and parallel execution of those operations here. So, and we run the Python programs to exploit better usage of those multiple processors across those Raspberry Pis. So these are the Raspberry Pis which we connect with each other to form the cluster so that our computing capabilities are increased so that the data that is getting collected over here can be processed across this cluster to realize this computer vision as well as the audio data to be processed in a small amount of time. And we also looking onto the load balancing at the fog gateway. So because a huge collection of data is getting originated from different physical things, so we make use of these high availability proxy settings for this so that the data can be made processed, the data can be made available and get processed toward the distributed Raspberry Pis so that the data realizations can be in a more real-time manner. So for this, we are using the high availability proxy, HA proxy software tool, along with the artificial intelligence techniques. So we make use of this HA proxy. So we make use of the load balancer among the two Raspberry Pis so that the data gets processed in a small amount of time here. So which we are realizing, so still it is in the development stage, is not yet completed. One of our my PhD scholar is working on this load balancing techniques for different set of sensors data that is getting collected over here in the gateway. So this is what the basic architecture which we are trying to implement here. So as of now, the virtual fog computing environment is realized. So we are trying to incorporate the better load balancing strategy so that the data get processed very quickly. So if you look to the data processing, that's what the second part of our presentation. How do we uh, implement the machine learning algorithms or the artificial intelligence techniques onto your uh, Raspberry Pis, in other terms, the resource constrained devices. So if you look to the machine learning process, the machine learning process is basically machine learning is basically a subfield of artificial intelligence, which makes the computers the ability to learn without being explicitly programmed. So this is the basic definition of this one. Now, if you try to understand here, the raw IoT data that's getting originated from this set of sensors, from the IoT sensors here. So we make use of this data that is getting originated from the IoT devices. By the processing of the data can be done in the two different steps. So the step one will be basically the training process, and the step two will be the inference process. So the training process, obviously, many people might be aware of what is meant by training. We are making training here. We are making a model to be trained with respect to the data that is getting originated from these particular IoT sensors. So here, on premises, or you can do through the help of a cloud hosted system. So you can build up a model here from the data that is getting originated. So you can use the deep learning frameworks or the deep learning techniques of the machine learning. So you give the training set data and you build up a model here. A model is getting generated over here. Now this trained model can be easily deployed onto your resource constrained computing device over here, which you can try to infer. So this inference can be done based on the new set of data that is getting from these IoT sensors. So the new data that gets from these the new data that is getting originated from the IoT sensors can be realized or can be inferred from this the model that has been already trained from the previous uh, infrastructure or the previous framework, and that particular data realizations can be done very in a quick and effective manner. So this can be done on your edge device. So of course, in the past, you have seen this is already been hosted on the cloud or onto your premises in the sense that AI computing infrastructure was made available to realize these new set of data that is getting over here. But nowadays, the trend is on towards deploying your machine learning models or your artificial intelligence techniques on directly onto your edge and the fog computing devices. So let us see in today's session how these things are getting realized over here. So in practice, just please try to understand there are two processes for this machine learning. One is on the training and the inference. Training, you can make your model to be trained on a high computing device, or when I say or here, the training process can also be deployed, and it also can be incorporated on your resource constrained devices. So the second step of your training process, that is what the OR process I told you, I'll get back to that later. So to have a more efficient model to be trained with respect to the data that is getting originated here, it is always preferable to train that model on a highly computing devices and deploy the model onto your resource constrained devices such as Raspberry Pis or your microcontrollers, or you can embed this particular model onto your own mobile phone, so that you can try to understand, or you can try to realize it for the new data that is comes from the different set of IoT sensors. So the tools that need to be people to be aware of, that how we can realize the AI and machine learning tools to be deployed onto your resource constrained devices. So the Google Brainchild, the TensorFlow, the Google's research works have realized into a very efficient manner. So Google has given certain tools for us. Of course, these are open source. You can make use of these tools for your end-to-end product deployment, as well as end-to-end development purpose. So here you can make use of these Python development tools. So far you have seen with the help of TensorFlow, you can try to load and pre-process the data. Then you can build your model. You can train it. You can make reuse of those models with respect to your own constraints, and you can deploy it.
Just interrupting, sir.
Yeah.
Excuse me, sir.
Yes,
Please
sir.
increase the font.
Yeah, so this is basically a screen print over here, sir. So let me just show you the browser over here. So instead of the screen print, let me go to the browser and show you the link here. All the links are provided over here. So here, yeah, I'm just increasing the font size. You can see tensorflow.org/learn. You can go to this particular website, and you have certain tools over here. So you can see the TensorFlow ecosystem. This is what the diagram which I have taken from here, the reference. So this tensorflow.org underscore slash learn. You can see the tools which the Google has developed for us. So this is a Python environment, and they have developed for us the JavaScript development tool, wherein you can build your machine learning model using TensorFlow.js. You can import that model and you can write it your own JavaScripts. You can build your own model based, you can train up and you can build up your own model, and you can deploy it onto your browser. That is, you are running your AI on the browser, or you can using the node.js server, you can deploy it onto your electronic gadgets, which are basically you can embed your code, that is the code consisting of AI, onto your systems. Similarly, now this Swift development is under progress. Of course, this is in the beta version. And now the important thing that everyone needs to be aware for this session, basically, I am looking onto something called TensorFlow Lite. So this TensorFlow Lite will enable us to deploy the AI model or the machine learning model onto your mobile or your embedded devices like Android, iOS, and Raspberry Pi. So today I have the Raspberry Pi with you. So I will try to show you how to use those programs. How can you deploy the machine learning models onto the Raspberry Pi? Of course, you can refer more information on the TensorFlow ecosystem, which is available on this link. So, so this is what just I put a screenshot. And yeah, after my presentation is over, I can share my slides to you all. So you can try to refer to these two things, and you can get an understanding here. So for the people who don't know what is basically a TensorFlow and why a TensorFlow is required, and what are the projects that have been undergoing, and how best we can make use of these TensorFlow for various applications. Basically, now the TensorFlow in the last decade and so, people have an maybe it is a misconception, or people have an understanding that TensorFlow can run only on GPUs. Let me say, this is not the case now. The technology is much advanced. Google APIs, TensorFlow APIs are very much now flexible to run not only on GPUs, you can run on your CPUs and you can run on your microcontrollers so that you can easily embed your AI and ML programs onto your electronic devices and which you can easily connect to your physical things for a better realization. So let me just quickly give you what this TensorFlow is. So TensorFlow is basically a data flow which is initially released on 2017 by the Google. So it is written in the C++ and it has a wrapper for Python and Java. You can easily have an interface with this Python and Javas for a better compatibility and better reusability of the codes to be run and to realize it. So basically, the initial version of TensorFlow.js is called as deeplearn.js. Now this deeplearn.js is changed to TensorFlow.js. So of course, the graphics processing unit or the graphics things can be easily realized with the help of your WebGL, which most of our web browsers do support, and as well as our microcontrollers do support this kind of facility over here. So you can infer means you can get the decisions, you can easily train as well as entirely on your browsers and on your uh, resource constrained devices. So here DeepLearn.js is now changed to this one. So in browser MLs, so this is a reference to your IBM. The IBM also has given this particular things. So the advantages having machine learning in the browser and as well as running these applications on the embedded systems is you need not install the drivers, you need not install any other software tools apart from these particular set of APIs. So you can easily interact with various applications. So your the graphical applications as well as real-time applications can be easily realized over with the help of deploying these AI methods. So you can as well as integrate your APIs with the sensors and the actuators and the physical things, which very much easily. And your the advantage of running your in browser is that is on the browser is the data stays on the client. You need not send it onto the cloud, not to any other system. So you need not transport the data. The advantage is you can have your privacy data can be processed on the browser itself. So of course, security also to some extent is been guaranteed for us so that the data is not going to be given to some other machine. So data stays on the client itself. So it is more advantages to have the security and the privacy aspects. And of course, you can also use your pre-trained models and which can easily import it onto your browser and you can infer for a better outputs and better outcomes for different set of applications. With the help of transfer learning, you can retrain the imported models depending on your applications. You can incorporate a new set of procedures. You can modify the existing methods for your set of applications. So of course, everything can be done on your browser itself. So that is what the advantage of having running your AI or ML methods on the browser as well as on basically it leads to your edge and the fog computing scenarios. So what is a tensor? So participants who are not aware of the sensors to just to have a quick idea, basically a tensor is a generalization of a vector or a matrix. So when you say generalization means you are trying to represent your quantities of information in terms of better representation for having an computational aspects in a very effective manner. So the general realizations of your vectors like your vector one-dimensional array or a matrix which is a two-dimensional array. So of course, a tensor is basically an n-dimensional array. So these tensors will be able to store our data in a more dimensional manner and for a better computational process can be easily realized so the data can be processed in a small amount of time, which is almost equivalent to your real-time processing of your data. So what is basically a tensor flow? A tensor flow is basically a common programming model, basically for achieving some parallel computations, which are going to be run for complex operations. So a very huge quantity of data can be processed in a small amount of time that will be made available with the help of this tensor flow. So TensorFlow uses the data flow graphs to represent our computations in the form of tensors, where a huge quantity of data can be represented. or a complex data can be represented for effective processing of the data in a real-time manner. So what are the benefits of using this graph? Yes, to quickly understand, you can realize the parallelism. So the advantage of parallelism is to execute multiple tasks at the same time and have different set of operations which can be applied on the different set of data values that
Excuse me,
originated.
excuse me,
Hello.
sir.
Yes,
Uh,
please.
just please go to previous slide, sir. As
Yeah.
I am also watching your slides, so
Oh, sorry. Yeah.
yes, yes.
Is this particular slide or this one?
TensorFlow, sir. TensorFlow.
TensorFlow, right. Yeah. No. If anyway, I will try to share. I will definitely share these slides to you all. So
Just
you can also have a copy at your end. If I have the option to share at this moment, let me just see here. Just quickly, I will try to share here.
no, it's okay, sir. It's okay. Just I will collect it later on.
Okay.
Please,
Okay.
just I want one minute.
Okay. Right. So here, the advantage of the TensorFlow is basically the TensorFlow is a representation of a data flow graph. So the data flow graph will allow us to have the parallel computing aspects in a more easy manner. So that is the most advantageous for running multiple tasks with different set of operations, which will be enable us for our IoT data that is getting originated from different set of devices. So the distributed execution, yes, this processing of the data. Of course, this distributed execution, one has to deploy a method or a methodology how we can try to realize this distributed execution. So using your Raspberry Pis or using your resource constrained devices, some of you can easily apply, or some of you can easily design a AI algorithm wherein you can make use of your distributed execution for your set of applications in a more easy manner, so that that can easily run on your CPUs as well as on your graphical processing units or on your tensor processing units. Of course, the each processing unit is going to be factored in terms of the number of cores available and the number of operations per second that can be done on this set of devices. CPUs will basically, usually if you have a resource computing device of up to 8 cores of CPUs, or less than 4 also can be made use of to run your TensorFlow programs. Graphical processing units will have more number of cores as well as more operations, data operations per second can be realized here. So TPUs are more higher in number, in the higher order. It is a factor of 128,000 data operations per second can be easily realized with the help of your tensors. So of course, this tensor for data flow graphs, the compilations is very much quick enough to generate the code can be easily run on your embedded systems or onto your browsers in a more easy manner. Of course, you can try to it is a highly portable one. You can port these particular models onto different set of devices for effective processing. So TensorFlow.js is basically machine learning capabilities which are going to be added for your web applications to run in a very effective manner. So there are a lot of APIs now are getting onto your market. So the Google is quickly trying to have more set of APIs here. I will show you what are the now the latest APIs which you can make use of these things. So TensorFlow.js. So Google has given three different set of tools here. One is TensorFlow. The second one is TensorFlow.js, and the third one is TensorFlow Lite. So please be aware that TensorFlow.js basically a JavaScript uh, application, the JavaScript library, which will enable us to use their APIs to have our own TensorFlow programming on our browser. Or not only on the browser, if with the help of Node.js, you can deploy it on your electronic gadget, in the sense electronic device. The third one is TensorFlow Lite. Basically, the Lite version is to enable us to deploy our machine learning processes to run on our mobile devices and other microcontrollers which are been having resource constraints, such as the capabilities of memory is very small in the sense that you have only few KBs of memory which are available for you to store to process it and to store and so on and so forth. That TensorFlow Lite will enable us. So at least TensorFlow.js will enable us to run on the browsers. One more important point: if people are able to develop and build a TensorFlow.js model, you can as well convert into TensorFlow Lite, a flat file system, and that flat file system can be easily deployed onto your resource constrained devices. So there's a lot of flexibility is there to develop your own set of machine learning algorithms to learn means to learn as well as to deploy it. Now the advantage of this TensorFlow is it can run on a different set of machines, Linux, Mac OS, iOS, Android, Raspberry Pi, but it has got a limitation on your Windows systems. But now that limitations are also being very much minimized with the latest methodologies is taking place in our scenario. So now why TensorFlow? Why we need to have it is offers a high flexibility. So basically that has been in the back end. You have the C++ implementations which can be easily ported and it can be modified. It can be easily deployable onto different set of devices and the different set of platforms which can be easily integrated with other set of software tools. With the help of APIs, you can try to integrate with them and have a more computational power. So TensorFlow supports distributed computing. That is what the major advantage of TensorFlow. So the distributed intelligence can be easily realized. So your fog computing environment or your edge computing devices, which are at most requirement of your distributed intelligence. So distributed computing aspect is very much needed for you to realize your edge computing and fog computing facilities. So which are basically nothing but your IoT teams of applications for this today's requirement. So that can be easily realized with the help of TensorFlow. So the need for TensorFlow is to have the distributed intelligence and the distributed computing capabilities. Coming to the third tool, TensorFlow Lite. So basically, the TensorFlow Lite is, of course, this is an open source, end-to-end product realizations can be done, and basically it follows the deep learning frameworks. So the deep learning is basically, you know, the meaning of a deep learning. Is one of the machine learning techniques, and of course, an artificial intelligence technique, wherein you have a complex network structure where your data is getting processed at several layers and at several levels to process a huge quantity of data that is basically your big data, or in other terms, the uh, 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 vast amount of data that is getting originated from different set of devices can be easily realized. So this TensorFlow Lights is capable enough for you to realize those deep learning applications in a more effective manner. And you can use this machine learning inferences directly onto your device. So the advantage is this is the low latency and a small binary size. So as I mentioned earlier, you can deploy your machine learning models of very uh, bigger sizes can be easily being deployed onto your small memory sizes devices where you can realize your AI processing to be very effective. So in other terms, you're performing machine learning on the devices at the edge of the network. So if you look to this diagram, this TensorFlow APIs, basically TensorFlow is the backend. The backend structure of this is basically it takes into the structure of Keras. So we have a low-level APIs that are already being developed for you. So the low-level APIs basically with the hardware devices to be integrated with easily, along with that TensorFlow Keras. The people have come across these particular functions to model your uh, data that is getting originated from your IoT devices. So once the data is being modeled, that model is being given to your TensorFlow Lite converter. So this TensorFlow Lite TF Lite, we call it as TF Lite converter. This converts this TensorFlow Lite converter converts to an appropriate flat file or a TensorFlow Lite flat buffer file. So that file can be easily deployable onto your client machine. So of course, now today's technology also has made us available to run entire this process onto your client machine too. So to make you to understand this particular TensorFlow Lite, the diagram I have made here. So the server can be basically your desktop workstation or desktop or your high-end computing device where you can build your own model with the data that is getting originated here, and you make use of this TF Lite converter from the TensorFlow Google's uh, tools. Once you convert it, you get that particular file. That file is going to be run on your CPUs or onto your GPUs or onto your neural networks or another set of models which are running onto your client machine. Basically, this can be your resource constrained computing device, such as Raspberry Pis or microcontrollers or a small embedded system with less memory and less CPU capabilities. So a small example here, which you can do the image classification. If you look to the image classification, basically, yeah, it's almost 11:30. So the image classification is one of those computer vision techniques, which basically requires a machine learning process and AI methods. So of course, for the last decade, people have applied various AI and ML techniques to have image classifications, image detections, and have other computer vision techniques to be modeled as well as run on a high computing devices with a GPUs and so on and so forth. But now, since the TensorFlow tools are being made available, please do remember. So you have a very ImageNet model is already available. People who are working on the computer vision, they know it very well. The ImageNet model now can be been after some works, it has been transformed to MobileNet by Alex, and that particular MobileNet model can be easily deployable, which has been converted to TF Lite, and it can be easily deployable onto your Raspberry Pi. So what we do once this particular model is deployed on your Raspberry Pi, what we do is we install the TensorFlow Lite interpreter on your Raspberry Pis or onto your electronic devices. So if you have a very highly resolution images or a very high size images of 1200 by 1200 pixels of images sizes, which we resize them, reshape them, we transform them into a 225 by 224 size with RGB colors. We try to transform that particular image, and we batch that particular images in terms of one dimension. So we add one image at a time. We try to, if you are having a video file, you can make that as a frame, and that frame can be given to this particular frame or this particular image. I'm talking about in two terms, the video as well as images here. So once you give it to your TensorFlow Lite model, you get the transform that particular into a set of array of values. These are your tensor values. The tensor output values will give the appropriate labels to understand what this particular image or the labeled image is all about. So whenever you give a new set of data, obviously this particular model is the model can generate the corresponding output in a less amount of time. Of course, in a milliseconds of time you can take it. So these are the basic steps given to you. So let us see how we can try to do the practicals. So one is you have a demo 1 and a demo 2. So that concludes the session. So the demo 1 is basically to run your AI on your browsers, and the demo 2, I have a Raspberry Pi with me, so I'll be taking the executions of running your model onto this particular Raspberry Pi model. So let us go with starting the demo. So predictions from a two-dimensional data using TensorFlow.js model. So of course, I will not write the code here. So let me just show you some of the programs which have already been executed here, which can run on the browser. Right, so let me just take a small example here. So see here, if you see the simple, I'm trying to run a AI model. So basically, I'm using the TensorFlow minimal versions of this JavaScript library file. So I think everybody knows this simple HTML script file. So and I am writing one JavaScript file, script2.js. So this particular script2.js is basically, what is this all about? So this script2.js is basically a simple neural network. So then a simple neural network, you are going to build up the model. So before we going to this, you have something called as a tensor two-dimensional array. So what is a tensor all about? So you can see, you can go to this particular website, TensorFlow.introduction. You can go to this TensorFlow. You can try to all the APIs and the models are available here. So you have a TensorFlow 2, the latest version, TensorFlow 2 API versions are there here. So this is basically the Python version. Let us go to the JavaScript version. So in the JavaScript version is this particular. See here you have something called the tensor. So this is basically a tensor with a single dimensional array. TF stands for the tensor 1D. So like this, one dimensional, two dimensional. If you see on the left side of my screen, two dimensional, three dimensional, four dimensional, five, six dimensional. The examples are given here. So you can run these examples. So how do you run it? Is basically you build up an HTML file. So you can include this tf.min.js, or you can download this tf.min.js file onto your local system. So you need not depend on your internet connection. Once you download your JavaScript file locally, you can run it, and you are written your own script file here. So this is basically your script2.js, which is trying to have this neural network model with the help of various tensor. So to understand what is a tensor, let me just run this one. You can simply run this example. Let me just run one example here. Okay, this is one just simple example, TensorFlow JS. You are trying to predict the value of y, and the corresponding code for this is the logic for this. Yes, this is a basically you're giving two x value. This is your x array with a different set of values of x, and you are trying to give the corresponding y values. And if you're looking for an unknown value, so this unknown value is something like your a tensor. You are giving an unknown value, which is trying to predict based on this data. So this data here I'm giving in terms of numerical values. This can also be done with the help of your images and so on and so forth by using your fit function. You are going to predict this one. So the model is gets trained with the help of these simple layers, simple layer of this particular form. That the diagram is which is looks like this. The diagram is, let me show you the diagram. So the diagram looks like this. Simply in an input layer, you have two set of hidden neurons, and sorry, here hidden layer you'll have a set of four neurons here, and a corresponding output layer, a simple neural network layer of this particular form. So so this is what the simple neural network. So you can include the TF script file here and your own. So here your own learning model. So this is another value here which have already been executed here with your different set of x values and with the different the corresponding y values here. So if the x values are x1 and x2 are 0 0, you get a y value 1. If x1 and x2 are 0.5 you get a value of y value 0.5. If x value is 1 and means x1 value is 1, x2 value is 1, you get a value y value as 0. Basically it is a inverse function, y is equal to x inverse. So here y value is going to obtain based on your x values, inversion of your x values. So here this is what your layers information. You have a there are hidden layers has got four units, four hidden layer, four neurons here. The input shape is 2, it gets x1 and x2 here, and the output is basically a 1 neuron as an output here. You know what is an activation function. So the neuron fires based on this particular sigma, on applying this sigmoidal function here. So you try to build up the neural network model. That's what the hidden layer and the output layer is been built up. So then you train up with respect to your sigmoidal functions, then your Gaussian distribution with the 0.1. Then you fit the model, you run the model for certain number of iterations. You try to get the corresponding prediction value for certain values. So you can display those set of values over here. So this everything can be run You can run, this is what your HTML script, and this is on the right side, you have your JavaScript, and these two things you are running on your browser. So once you run it on the browser, the output looks like this. So the complete iteration values you can see here, and the corresponding output can be done. So the same thing I'm now running on this particular screen over here. So this particular steps. So this program I'm opening with my browser, or maybe this is another program. So you can go to your console. Of course, yeah, this is another program. Let me just show this particular program. It's the PF. This is one.html, one.html is this particular thing. Oh, this is script2.js. Yeah, this is the neural network. Yes, TensorFlow.js.
Uh, Sir, our next session is scheduled after
Yeah, just wind up now.
actually
Okay, just one more demo. Let me just show you here. So this
you
is,
can take 4 minutes, but please try to bind it. So.
yeah, I'm just another demo. Let me just show the another demo. So this demo is basically on the Raspberry Pi. So how do you run it on the Raspberry Pi? So I am connecting Raspberry Pi onto my laptop here now. So those people who are not aware of how do you make use of this one, you can follow these steps.
Let me know, sir, if you want to extend it for more than 15 minutes, then I can ask from other
No,
speakers.
no, sir. I just I need another 10 minutes only. I'll give the
you think,
time for question answers after 10 minutes. Just this is one. I'll just do the demo and I'll wind up.
okay, sir. If you think that something important is missing and can be added here, then I can request
Just I
to the
want
next.
to show how people can, means how our computer vision algorithms using AI can run on the Raspberry Pi. That's what I'm trying to show you here. So let me just complete this one, sir. Just 5 minutes only. I will not write the code. Of course, it will take the time for that. So let me just only give the demo here. So this is how we are going to connect a Raspberry Pi onto the laptop. So this is the Raspberry Pi, which is very near to me. It is only powered up. So I am trying to bring it to my system here. You can use Xming server, which can run on the background. So once it runs, you can use applications which are running on the Raspberry Pi can be easily seen on my laptop screen. So that's what actually I'm doing here. So here on the Raspberry Pi, basically, people might not know I have created a virtual environment. So that is what virtual environment computer vision work on CVE 450. That is always whenever you run your applications, please create your own virtual environments. So this is the virtual environment I'm running here. So OpenCV, please don't install OpenCV with a pip install or your sudo apt-get install OpenCV on Raspberry Pis. Never do that one. Please, the one which the procedures on my lab on my presentation, it is there. So you can apply those things. So in order to install OpenCV on the Raspberry Pi, it will take almost 5 to 6 hours of time. So I'm just sharing that particular thing for you. And also I installed this Jupyter notebook onto this Raspberry Pi. So now just it will take a few seconds. So you can run, this is what an example which I like to show you. You can run your all your machine learning algorithms on the Raspberry Pis. So Jupyter is now getting started up. A session is going to be started up. Once it starts, I'll show you some small output which can be computer vision algorithms, which I've shown on the slides. Then we'll wind up. So here, so this is one. This is what predictions of from two-dimensional data, that is X and Y data. You have just, so this my, yeah, so this Jupyter is now started onto my things on my Raspberry Pi. So here we have written a small image classification algorithm. So let me open that. So here, so I think people who have done some programming on the GPUs and high computational device, they know this environment very well. But because of these lockdowns and all, people who don't have access to their computer lab workstations and the GPUs, you can simply buy a Raspberry Pi with a small amount. So of course, this Raspberry Pi which I'm using is Raspberry Pi 3B. In fact, now the latest version 4B is also there, which high RAM and other computational aspects. So you can realize your machine learning algorithms on these edge computing devices in a more efficient manner. So if you see here, I am trying to run a small program here. It is now started. So just yeah, the term reference to the process executed on. Okay, some now this is what the errors is comes here. You can see these particular statements can be easily run on this. So the image classifications here, what in this program is we have developed deployed this mobile net, the quantization values for the labels purpose, and as well as you can this TensorFlow Lite interpreter. This is what the TF Lite runtime interpreter. So this TF Lite TensorFlow Lite run interpreter is been now installed onto my Raspberry Pi. So this interpreter will try to look into this particular models. So this is the model which is generated from my laptop, the mobile net quantization values. And now whenever you give an input, so this is you are making the shape from your uh, shape from the 1224 to 224, 224 by 3 with one dimension you are making here, and you are trying to predict those set of values here. So that is the outputs. So these screens are available on the to the laptop. You can try to understand. You can test it with different set of images. So all these things have been made available on the internet, and you can try for this. So the point here is, let me just conclude here. So this so far the IoT devices were all about collecting the data. So please remember, a lot of techniques, a lot of communication strategies, a lot of things have been made available with respect to the IoT. Is basically those wireless sensor networks and the IoT communication topologies and strategies were basically trying to collect the data. But of course, the processing the data and trying to realize it with a smarter decisions using AI methods and all was very minimal. So, and that to that minimal things have been happening with respect to the cloud managements. But now people started realizing with the advancements in hardware technology and advancements in the software technologies, people have now started to realize that you can try to deploy your own AI and ML methods onto your electronic gadgets. Just like what I have shown you, you can run it on your browser as well as you can run it on your Raspberry Pi 2. So this is how this is the advantages there. You are decreasing the costs of the CPUs, memories, and storage. Your resource constrained devices, you are applying your AIoTs. So you have a convergence of IT and operational technologies. So you are leveraging your application analytics to run on your gadgets. So you are merging your AI with your IoT things. And so your unification of your life cycle for a heterogeneous set of things, and you can have your real-time analytics in a very better way. So this is how I'd like to conclude it. And my research works, and currently what I am doing, you can go to Google Scholar. So in the Scholar, you can just type my name, and you'll get my the works which are being now uh, outcomes are being presented over here. So now I open the session. That last 10 minutes is there. So I open the session for the question and answers. Thank you. Of course, because of the time constraint, I could not complete this demos in some way. But anyway, nevertheless, I have just shown you how to make use of this. Yeah. Any doubt?
One question is, sir, from
Yeah.
Meenal Patel, and she's asking that what is the output of last case study using mobile net based pre-trained model?
Sorry, mobile net is basically a classification. You try to give an input of an image and you try to find out what that particular image is all about. Whether it is an animal, if it's animal, what is the name of that animal? If it is a bird, what is the name of that bird? If it's an object, a physical object is this. So already that mobile net model is been having almost 1,000 plus of labels which have been quantized to classify different set of physical objects. So we are making that model to be running on our resource constrained devices to predict a corresponding new input. If you are given, it may be classified into a particular type of entity. So that is the output of that particular second case study, please.
If there is any more question, participants, then you can ask directly with Professor Nagender, or you can put your question here in chat box. I will repeat that one. So well, sir. So in today's session, Professor Nagender has well delivered that has differentiated well the difference between edge computing, fog computing, and cloud computing, and he has elaborated it very nicely. And then subsequently, he described that what is tensor and then TensorFlow, and we have studied tensor in graduations, and that it is highly used in higher dimensions for n-dimensional, and mathematicians predict even astronomical and many things in tensor flows, and he has well elaborated its practical applications. And then he has cleared the concept that many people are confused that it can run only on GPUs, but Professor has cleared it that it can be run on CPU or microcontrollers also. And he has well elaborated that how you can use the open source tool which is available on Google, and you can use all these things for IoTs. And he's also clarified that if you want to do research in fog computing, etc., integrated, then you should not take the project initially on fog, but take some small project on IoT. And when you get the experience, then do these things, integrate on fog integrated things. In tomorrow's lecture also, we will see some cloud simulators also. So these lectures are well connected. So thank you, Professor Dr. Nagender Kumar sir, for giving your precious time and for enlightening us with your knowledge, and all the participants. I was listening your lecture carefully. Today I have got time. It was Sunday, and so thank you, sir.
Yeah, so thank you, one and all. Really, it was a very nice session. And of course, thank you for giving me this opportunity. So my email is already given on the chat box, and you can reach me over there if you have any doubts. So I will be very much happy to try to provide some kind of help, or my experience I can share with you in any kind of projects and so on and so forth. So even I will send my presentation slides to Pawan Kumar sir, and sir may try to share with you all. So those are the slides of mine only, so there is no problem of any copyrights and so on and so forth. Yeah, thank you, one and all.
Sure.
Thank you. Have a good day. Have a good time. So all the best. Thank you.
Thank you, sir. Good.